Welcome to the DIY Honda Garage channel. The DTC P0118 indicates a problem related to the Engine Coolant Temperature ECT Sensor 1 circuit, specifically a high voltage reading. This diagnostic trouble code, DTC, is critical for the engine's performance as the ECT sensor measures the temperature of the engine coolant. Accurate temperature readings are essential for the engine control unit, ECU, to manage fuel injection, ignition timing, and emissions. The ECT sensor is usually located near the thermostat housing, connected to the engine block, which allows it to gauge the coolant temperature effectively. The error can lead to poor engine performance, excessive fuel consumption, and potential damage to engine components if not addressed promptly. This guide outlines a comprehensive troubleshooting approach to resolving the P0118 issue. Final repair verification is crucial to ensure all issues have been adequately addressed. Start by turning the ignition to the lock position and meticulously reconnect all connectors that were previously disconnected during troubleshooting. After reconnecting, use the HDS to exit from the SCS short mode and restore normal operation. Turn the ignition switch back to the on position and reset the PCM using the HDS. Follow this up by performing the idle learn procedure as required. Finally, check the system again with the HDS to identify whether DTC P0118 persists. If it does, revisit previous steps. If it clears, the repairs have likely been successful. Preventive maintenance is an essential strategy for avoiding future occurrences of the DTC P0118 code. Regular inspection of electrical connections and wiring associated with the ECT sensor helps to catch potential issues before they develop into full-blown failures. Additionally, ensuring that connectors remain clean and free of corrosion is vital for maintaining good electrical conductivity. If updates are available for the PCM software, applying them can mitigate issues by improving how the unit interprets data from the ECT sensor. Incorporating these practices into a regular maintenance schedule can prolong the life of engine components and enhance overall vehicle performance. In conclusion, diagnosing and resolving the DTC P0118 requires a systematic approach focused on verifying electrical connections, testing continuity in wires, and assessing the functionality of the ECT sensor. Key steps such as verifying voltage readings and continuity checks at specific test points are essential for pinpointing issues accurately. If a fault is determined in the ECT sensor, prompt replacement is necessary to prevent adverse engine performance and potential overheating. Also, incorporating regular preventive maintenance measures can mitigate future risks associated with high voltage readings in sensor circuits. By following this guide, technicians can effectively manage issues relating to DTC P0118. Ensuring the Honda Accord operates at its best. The Engine Coolant Temperature Sensor plays a pivotal role in engine management by providing crucial data to the Engine Control Module, ECM, which relies on this information for optimal performance. A high voltage reading from this sensor indicates a malfunction, which could affect various engine functions, such as fuel mixture and ignition timing. The ECT sensor is typically situated close to the thermostat housing of most Honda Accords, ensuring that it's directly in contact with the engine coolant. This strategic placement allows for accurate readings of the coolant temperature as it circulates through the engine. The sensor is connected to the harness via a 2-pin connector that can often be a source of issues due to corrosion or disconnection. Proper functioning of the ECT sensor is crucial for maintaining an efficient engine and preventing overheating, which could lead to severe engine damage. There are several potential causes for the DTC P0118 error code. The most direct cause may be a failed ECT sensor, which can lead to erroneous voltage readings being sent to the ECM. Additionally, poor connections at the ECT sensor itself or the powertrain control module, PCM, could disrupt the flow of signals, resulting in the high voltage malfunction. It's essential to inspect wiring for any signs of wear, corrosion, or disconnections leading to open circuits, which could also result in this DTC. Finally, software issues within the PCM may cause the sensor to report incorrect data, prompting further investigation. Each of these causes must be thoroughly assessed to determine the precise issue contributing to the P0118 code. When the P0118 code is present, various symptoms can manifest in the vehicle's operation. One of the most prominent symptoms is engine overheating, as inaccurate readings from the ECT sensor can lead to improper adjustments in coolant flow. Another common symptom is poor fuel economy, as the ECM relies on correct temperature readings to optimize fuel mixture and timing. Drivers may also experience rough idling as the engine struggles to maintain a consistent operating temperature. Additionally, the vehicle may throw other codes related to fuel and emissions that can complicate diagnostics. Recognizing these symptoms early can lead to quicker resolutions and prevent long-term damage to the engine and associated systems. To begin troubleshooting the P0118 code, first turn the ignition switch to the on position or start the engine, placing it in the on mode. Using the Honda Diagnostic System, HDS, check the current parameter readings for the ECT sensor 1. The expected reading should be above 4.92 volts as a signal threshold. If the current conditions match this threshold, it indicates that the problem can be duplicated, and you will proceed to the next step. However, if the ECT sensor does not meet this threshold, it might point to intermittent issues such as poor connections or loose terminals between the ECT sensor and the PCM. Addressing these irregular connections can often resolve the issue before advancing to more in-depth diagnostics. After verifying the initial conditions, turn the ignition to the lock position to ensure safety before proceeding. Disconnect the 2P connector of the ECT sensor to isolate it from the system. Connect a jumper wire between terminals A and B at the ECT sensor connector. Terminal A connects to the gray wire, and terminal B connects to the PNK pink wire. After establishing this connection, restore power by turning the ignition switch to the on position. Use the HDS to verify the ECT sensor readings again. They should still indicate values greater than 4.92 volts. If they do, this indicates the sensor itself could be functional, and it suggests moving to the next troubleshooting step. If they do not, the ECT sensor likely requires replacement. With the jumper wire removed, turn the ignition switch back to the on position to assess the voltage at the test points. The checks provided focus on two main lines, the TW line and the SG2 line. With the ECT sensor disconnected, measure the voltage at the TW line, test point 1 at the PNK wire, against a solid body ground, test point 2. The expected voltage should be around 5.0 volts. If this value is confirmed, it indicates that the wiring from the sensor to the PCM is intact, and you should proceed to test for continuity in the next step. If the voltage does not meet the expected value, check for potential breaks in the wiring harness or defective components. Next, with the ignition turned off again for safety, jump the SCS line using the HDS to activate the short circuit mode. Disconnect the PCM connector labeled C, which is a 51-pin connector. With the ECT sensor still disconnected, check for continuity between the SG2 wire at the ECT sensor and the corresponding pin, number 31 gray wire, in the PCM connector. Continuity must be verified to ensure that the wire is intact. If continuity is confirmed, this wire is functional, leading to the determination that the PCM may require an update with the latest software, or a known good PCM may need to be installed. If there is no continuity, proceed to repair any detected open circuits in the wire. For the final continuity check, again ensure the ignition is in the off position while working on the wiring. Jump the SCS line once again to activate the short circuit mode. Proceed to disconnect PCM connector B, which also contains 51 pins. Then, test for continuity between the TW wire, pin number 2, PNK, at the ECT2P connector and the PCM connector's corresponding terminal, B50 PNK. If continuity is confirmed, the TW wire is operational, and you may need to update the PCM software if it is outdated, or swap in a known good PCM and check functionality afterward. In the absence of continuity, it indicates an open circuit that needs repair between the PCM connector and the sensor. Please like and subscribe to the channel. See you next time!